This is the review for the quiz section 6.3 to 6.6, part 2. Problem 7 is on page 473, number 21. Using the law of sines, solve the triangle for all possible conditions. Remember that when we solve a triangle using the law of sines, there's the possibility that there could be 0 solutions, 1 solution, or 2 solutions. We always set up the problem with the thought that there might be 2 solutions. So I'm going to start by making 2 charts on the off chance that there might be a second solution. Oops. Alright, so the first thing that I'm going to find is angle C. How do I know that's what I'm looking for? Well, I know side A and angle A. And the only other piece of information I have is side C, so I must need to find angle C. Alright, so I'm going to do my cross multiplying. I get 20 sine of C is equal to 45 sine of 125. I divide by 20, and I'm going to inverse sine that answer. But what's going to happen is, when I evaluated this part, I got 1.843 approximately. And I try to take the inverse sine, and it gives me a big old fat error symbol. The reason that you can't take the inverse sine of 1.843 is because both sine and cosine fluctuate between +1 and -1. So if you're trying to find an angle measurement, but the value you have is greater than 1 or smaller than -1, you're not going to be able to find it. So we say this triangle has no solution. The nice thing about a no solution problem is you know at the very first step. It's not going to happen that you're going to find some information and then something later goes wrong. It'll always be the first step of the problem where all of a sudden you will get an error. We're going to try that again with page 474, number 24. And I'm going to start by setting up my 2 charts. So side A is 75, side B is 100, and angle A is 30. Here are my 2 charts. Looking at this information, I notice that the first thing I'm going to have to find is angle B. I know side A and side B, or side A and angle A. And the only other piece of information I have is I have side B, so I need to find angle B. So the sine of 30 over 75 is equal to the sine of B over 100. So you should be doing the inverse sine of 100 times the sine of 30 divided by 75. And you get approximately 41.8 degrees. So that time, I know I've got at least 1 solution. If a second solution exists, then angle B in the second case would be 180 minus 41.8, which is 142.5. As long as the sum of the 2 angles I know do not exceed 180 degrees, the second solution exists. Well, 30 plus 142.5 is 172.5, so it's not bigger than, it's not 142.5. I'm looking at the wrong place. Sorry about that. It is 138.2. So when I add those two, I get 168.2. Since A and B do not exceed 180 degrees, the second solution exists. Remember, the reason there is a second solution is because when you do an inverse sine in your calculator, the answer you get will either be in quadrant 1 or it'll be a negative value in quadrant 4. But we know that sines are positive in both quadrants 1 and 2. So if there's a second solution, it's 180 minus the angle from the first solution. Alright, going back. Now that I know angle B for both of these, now I'll find angle C by subtracting the original two angles from 180. So over here I get 108.2 degrees, and the second solution I get 11.8 degrees. And now that I know sides or angle C for both of these, now I can go find side C. You're going to have to use the law of sines for both of them. So the sine of 30 degrees over 75 is equal to the sine of 108.2 over C. In the second solution, it's the sine of 30 over 75 is equal to the sine of 11.8 over C. C over here is going to be 75 times the sine of 108.2 divided by the sine of 30, which is going to give you approximately 142.5. In the second solution, C is 75 times the sine of 11.8 divided by the sine of 30, and that's going to give you approximately 30.7. So this problem under these given conditions gave you two solutions. Don't forget to check. The next problem is page 482, number 46. Airport B is 300 miles from Airport A at a bearing of north 50 degrees east. A pilot wishing to fly from A to B mistakenly flies due east at 200 miles an hour for 30 minutes when he notices his error. In the first part of this problem, we want to find how far is the pilot from his destination at the time he notices his error. So, first of all, the bearing of north 50 degrees east. Remember, bearing is a direction from the y-axis as opposed to the x-axis, which is what we use for reference angles. I know the distance from A to B is 300 miles, but he doesn't start by going that direction. He goes this direction. He travels 200 miles an hour for 30 minutes, which means he goes 100 miles. So now I know that side of the triangle. What we want to know is how far is he from his destination when he realizes he made a mistake. Well, since I know the bearing, I also know this angle. It's got to be 40 degrees because those two angles there are complementary and should add up to 90 degrees. Well, I have side angle side. When you have side angle side, you can use the law of cosines to solve. So x squared is equal to 300 squared plus 100 squared minus 300 times 100, minus negative 2. Let's do that. Minus 2 times 300 times 100 times the cosine of 40 degrees. Don't forget to square your answer at the end, and you find out that x is approximately 232.5 miles. You actually need to know that answer in order to do part B. Because in part B it says, what bearing should he head his plane in order to arrive at Airport B? Well, I need to know this answer here. But in order to know that answer, it might be helpful if I know all of this angle that I'll call C because I didn't have it labeled yet. If I know that whole angle C, I can take away the right angle part of it and be left with the angle I'm looking for, and then I can find its bearing. So I'm going to use the law of cosines in order to find angle C. The reason I choose to use the law of cosines rather than the law of sines is because if I use the law of sines, the next angle you have to find has to be the smallest of the two remaining angles. C is not the smallest. B is. So you'd actually have to find angle B first with the law of sines, and then find angle C, and then you can finish the problem. If you use the law of cosines instead, which says that the cosine of angle C is C squared minus A squared minus B squared over negative 2AB, you don't have to worry about that ambiguity and finding the smaller angle first. So I'm going to do 300 squared minus 100 squared minus 232.5 squared divided by negative 2 times 100 times 232.5. When I put this into my calculator, I always evaluate the numerator first, and then I divide it by the denominator in an extra set of parentheses. When I take the inverse cosine of that angle, I should find out that C is approximately 124 degrees. But that's not my bearing. I need to subtract the right angle from it. And I find out that the little angle I'm left with is 34 degrees. So this angle here, if I write it using a bearing, it's going to be north 34 degrees east. And that's the direction I need to head my plane in order to arrive at airport B. The next problem is page 460, number 55. They want us to find the area of a triangle with sides 10 and 22 and an included angle of 10. Well, remember there are two ways to find the area of a triangle when you don't know the height or altitude. In this case, I know my triangle looks like this. When you know side angle side, the formula for finding the area of the triangle is 1/2 of one side times the other side times the sine of the included angle. And I find out that the area is approximately 19.1 square units. We actually had another way of finding the area of a triangle if I know all three sides. It was called Heron's formula. And just to review it real fast, Heron's formula was K equals the square root of S, S minus A, S minus B, S minus C, where S is 1/2 of the perimeter. And that's a better way of finding the area of a triangle if all you know are the three sides and you don't know any of the angles. Problem 11 is page 449, number 29. It says the cosine of 30 degrees squared minus the sine of 30 degrees squared. Well, the cosine of 30 degrees is the square root of 3 over 2. And the sine of 30 degrees is 1/2. Well, first I'm going to square those. Square root of 3 over 2 squared is 3 over 4. 1/2 squared is 1/4. 3/4 minus 1/4 is 2/4, and 2/4 reduces to 1/2. Or you probably could have just done that on your calculator, and the answer would have given you 0.5, which you know is 1/2. The only time doing it the long way is a good idea, is if the answer you get is something that cannot be turned back into a fraction. The last problem in the review asks you to solve triangle ABC if side A is 3, side B is 4, and angle C is 53 degrees. And we ran across this problem before, and when we did, we found out that depending on how you did the problem, your answers varied, I would say significantly. Normally they don't, so I'm not sure why this particular problem the answers varied more than they should. Well, if you go and set up your chart, you're going to find out right away that you cannot use the law of sines to solve this problem, or at least to start it off, because you don't know an angle and its corresponding side. So we're going to have to use the law of cosines in order to start the problem. So side C squared is going to be the sum of the squares of the other two sides minus 2 times 3 times 4 times the cosine of 53 degrees. Take the square root and you find out that C is approximately 3.2. Depending on how you round this answer, your answers will come out to be different. Since both A and B were actually rounded to the 10th place, I rounded side C to the 10th place and I got 3.2. Now you have a choice. Since you need to find a missing angle in order to finish the problem, you can either use the law of cosines to find A or B, and it doesn't matter which. If you choose to use the law of sines instead to find a missing angle, you have to find the measure of the smaller angle. In this case, that would be A. So I would do the sine of 53 degrees over 3.2 is equal to the sine of A over 3. 3 times the sine of 53 degrees divided by 3.2, inverse sine, is going to give you an answer of approximately 48.5 degrees. And once you know angle A, you can find angle B by subtracting 180 minus 53 minus 48.5, and you get 78.5. If instead you decide you're going to use the law of cosines, you're going to get angle A is about 46.7 and B is 80.3. I'm not sure why it varies that much, but it does. And that is the review for quiz 6.3 to 6.6.